Okay, here we go. A 6-foot board rests under a doorknob, and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? Okay, so what we have here is a door. The doorknob's right there, and they have placed a 6-foot long board up under the doorknob, I guess to, prevent somebody from opening the door and coming in. And they say that the board is 6 feet long, and then the board is 5 feet away, like the base of it is 5 feet away from the door. They want you to figure out how high above the ground is the doorknob, so this height. Well, what has been given to us? Right, a leg and the hypotenuse. Remember, whenever the door and the wall, whenever the door and the floor meet, doesn't that make a 90-degree angle? So since this is a right triangle, we'll be using what we learned yesterday, the Pythagorean theorem. And like Naya said, we are given a leg and the hypotenuse. So we're trying to figure out the other leg. Now, in the Pythagorean theorem, aren't A and B the legs and C is the hypotenuse? So for A, I can go ahead and plug in 5, and then don't forget to square it. B is unknown, so I plug in X, or you could keep it B. It doesn't really matter. And then for C, I would plug in 6 and square it. So now I simplify by actually squaring the 5 and getting 25. And then 6 squared is 36. Now to solve for X, what do I need to do next? And so X squared now equals what? 11. And now to solve for X, what do I have to do? Square root to cancel out that 2, and then square root this side. But that's not a perfect square, and we don't want the answers in decimal form, so you're just going to keep it square root of 11. Well, on the test next week, all the answers are going to be in radical form, so just leave it in radical form. Okay, you try number 2. It's the same situation as the previous problem. It's a 5-foot board resting under a doorknob, and the base of the board is 3.5 feet away from the bottom of the floor. Approximately how high above the ground is the doorknob? So, in this case, like the door would be this side, and then this would be the ground. So the doorknob would be like right here, and the board sitting under it. And how long is the board? 5. And the base of the board is how far from the bottom of the door? Right. And so we're trying to figure out how high above the ground is the doorknob. Okay, so it's a right triangle because whenever the door and the floor come together, that forms a 90-degree angle. And so you use Pythagorean theorem. What could we plug in for A? Right? Or you could have put X, because A and B, it doesn't matter what you do. And then, but if you put 3.5 there, now you need to put X there. And then your hypotenuse, which is always across from the right angle, is 5 squared. So now what is 3.5 squared? And then 5 squared is 25. So now what do you need to do? And so now we have X squared equals, and now what do we do? Square root it, and so X equals, yeah. Okay, so tomorrow, I'm not done yet, don't get excited. Tomorrow, we're going to go back to Pythagorean theorem problems, but they're not all going to have nice numbers like 5 or, up here it was whole numbers like 5, 13, 12, 13. You're going to have triangles where a side may be the square root of 8. So for that reason, today on page 6, we're going to practice simplifying radicals. Is it 6 or 7? 7. 7. Okay, so today on page 7, we're going to go practice simplifying radicals. Okay, so number 1. We're trying to simplify the square root of 600. So you do a factor tree. What numbers multiply to 600? Okay, you could use 100 times 6. Then what numbers multiply to 100? Okay. What numbers multiply to 6? What numbers multiply to 10? Oops, I don't know why I wrote it like that. And then another 10 is another 5 and a 2, and then 3 just comes down because it's prime, and so does the 2. Once you have written out all the factors and their prime numbers, what do you now do? You circle pairs. So like there's a pair of 5s, and there's a pair of 2s. Now remember, in the pairs, one gets killed, one gets kicked out. So in the pair of 2s, one gets killed, one gets kicked out. What happens when they're both kicked out together? They multiply, so you now have 10 on the outside. And then whatever was not circled was being good, and they go back inside and multiply together, so that would be 6. Now you can check these. Everybody type in the square root of 600. Okay, everybody type, Zach, turn around so people can pay attention. Type in the square root of 600. Zach, is that not your name? Turn around and let him pay attention. Okay, when you type in the square root of 600, what do you get? Okay, now type in what we got for our answer, 10 square roots of 6. You get the same thing, right? So that's how you know that this is the right answer. Okay, now let's skip down to a problem like number 6. What's different about it? Okay, but at first, you just ignore it. That's a kid that's already been kicked out, so just ignore them. Factor tree this. What are numbers that multiply to 256? Okay, let's try that. 256 divided by 16 is 16 to 16. And then wouldn't that become a 4 times a 4? And then that would become a 4 times a 4? And then wouldn't each of those 4s become sets of 2s? So what happens? Everybody gets circled and then either killed or kicked out, right? So for that reason, since nobody's being good, there's no need for a radical anymore. There's no need for the house because nobody's going back in it. One of each gets killed and then the other gets kicked out, and don't they multiply together? Okay, what's 2 times 2 times 2 times 2? No, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. But right, don't forget, pay attention. Don't forget that that's not the final answer because that 3 was already on the outside, which makes the final answer what? 48. Now, I want everybody to type in 3 square roots of 256 in your calculator. Because it was a learning opportunity. Okay, see how it gives you the answer? Why did that happen? Why did it give you the answer? But, okay, type in the square root of 256. Which means the square root of 256 is a what? Perfect square. That's why when you typed it in, it gave you the answer right away because this is a perfect square. So I would always type in something first before you factor tree it because you could just be wasting your time doing the factor tree when you could have just typed it in. So type in number 7. Type in 4 square roots of 196. So doesn't that mean the square root of 196 was a perfect square? It's 14, and 14 times 4 is how it got 56. Now type in 7 square roots of 700. And you get a what? Marcus, pay attention. Right, a decimal, which means we're not dealing with a perfect square, so for this one we must factor tree. So Marcus, why don't you help us out? What are factors of 700? Okay, factors of 70. Factors of 10. And then factors of 10. And then these are primes, so just drop them down. Okay, now what do I do? Okay, first you got to circle the pairs. So you have a pair of 2s and then a pair of 5s. So the only thing not in a pair is the what? So it gets to go back inside the house. And then one of each of the pairs gets killed, the others get kicked out, making what on the outside? But that's not the final answer, because what else do you have to worry about? The 7 that was already outside that will now make this 10 become a 70. You multiply. He added instead of multiplying. Okay. Now it is your job to finish page 7 and 8. If you have questions, you can raise your hand and I will come to you, or you can just come up here and I will answer them. But you need to be working on page 7 and 8.